Today we discuss relativistic electrodynamics. We first see gauge transformation. Gauge transformation. At first, we write the gauge equation as A dash equal to A plus gradient of lambda and phi dash equal to phi minus del lambda by del t, which means if we transform the vector potential A to A dash, then A dash will be A plus gradient of lambda, and if we transform the scalar potential phi to phi dash, then phi dash will be phi minus del lambda del t. Next, we discuss gauge transformation condition. First, Coulomb gauge condition. C-O-U-L-O-M-B. Coulomb gauge condition. It will be grad dot del dot A is always equal to 0. Next, Lorentz gauge condition. Lorentz gauge condition. Del dot A equals to minus mu 0 epsilon 0 del phi del t. Now we discuss the most important formula regarding electric field and magnetic field in time varying field. E will be minus grad phi minus del A del t, and V will be del cross A. Now we see the Lorentz transformation. Lorentz transformation. Which I written as the tensor form, which is x dash y dash z dash t dash equals to gamma 0 0 y beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma into x y z t. This will be the Lorentz transformation. Next, we see the Lorentz invariant quantity. Lorentz invariant quantity. First will be charge will be invariant under the Lorentz transformation. Number 2 will be E dot V. Number 3 E square minus C square V square. Number 4 mod of E square minus mod of V square. Number 5 x square plus y square plus z square minus c square t square. Number 6 D-Alembert-Sen operator, which is written del square minus 1 by c square del square del t square. It's also the invariant under Lorentz transformation. Next, E square minus p square by c square. 8 some 4 fourths dot 4 velocity, also the invariant under the Lorentz transformation. So this 8 quantity will be invariant under the Lorentz transformation. Next we see length contraction. Which is equal to L equal to L0 by gamma or L0 into root over of 1 minus V square by C square, where L is measured in earth frame or is the S frame, where L0 is measured in S dash frame, which is also called proper length. Next we see time dilation. T equals to T0 gamma or T0 by root over of 1 minus V square by C square. Here also T equals to the measure in S frame and T0 will be measured in S dash frame. Now we will see electric field and magnetic field transformation S to S dash frame. Electric field and magnetic field transformation. First we see electric field transformation. Ex dash always Ex when the S dash frame moving along X axis. Next Uy dash gamma Uy minus Bz V. Ez dash equal to gamma into Ez plus VVy. Next, for magnetic field Vx dash equal to Vx, when we consider the S dash frame moving along x-axis with the velocity v, then Vy dash equals to gamma into By plus V by c square Ez. So also Vz dash equal to gamma into Vz minus V by c square Ey. Next we see the energy momentum transformation. Energy momentum transformation. We write P1 dash, P2 dash, P3 dash, P4 dash equals to gamma 0 0 y beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma into P1 P2 P3 P4, where P1 dash equal to Px dash, P2 dash equal to Py dash, P3 dash equal to Pz dash, and P4 dash equal to I by E dash by C. Similarly, P1 equal to Px, P2 equal to Py, P3 equal to Pz, and P4 equal to I by C. Next we see scalar and vector potential transformation. Scalar and vector potential transformation. Here we write A1 dash, A2 dash, A3 dash, A4 dash equals to gamma 0 0 y beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma into A1 A2 A3 A4, where A mu will be Ax A y z into I phi by C, and A mu dash will be Ax dash A y dash A z dash I phi dash by C. Next we see current and charge density transformation. Current and charge density. Transformation. we write jx dash jy dash jz dash and jt dash equals to gamma 0 0 y beta gamma 0 1 0 0 0 0 1 0 minus I beta gamma 0 0 gamma into jx jy jz jt, where j mu equal to jx jy jz into I 0 and j mu dash equal to jx dash jy dash jz dash I 0 dash. Thank you.